Hello, everyone. We are very, very happy to welcome you this evening to our Women in Technology and Trades Tech Talk, focused on machine learning and how it is transforming healthcare. So thanks very much for joining us this evening. My name is Rebecca Isawa. I'm the program manager at Mohawk College in continuing education, and I take care of the technology and trades portfolio. I'm also really happy to have been a participant in our Mohawk College Women in Technology and Trades group since its inception back in 2018. Part of our initiative in creating awareness and making connections and finding the opportunities in technology and trades is providing insights into these really interesting and emerging technologies and how they affect our everyday lives. Tonight is one of those times. And it actually represents the fourth Tech Talk that has been sponsored by Women in Technology and Trades. The past three you can find on our website, one on renewable energy, the other on augmented and virtual reality, and the first one we did on artificial intelligence. So today we are going to be focused, as mentioned, on how machine learning is transforming healthcare. Machine learning is a subfield of artificial intelligence, and it has practically endless applications in a number of different industries, specifically healthcare, very relevant and timely into everything the world has been going through. Today, machine learning is transforming clinical decision support systems and admin processes. They're doing this through early identification of disease, tailored treatments, precision medical solutions, and tons more. And I am now going to introduce you to our expert. We are really thrilled to have you with us, Afraz. And to everybody, I'd like to introduce to you Dr. Afraz Syed, PhD and professor here at Mohawk College. Afraz has a genuine passion for research in machine learning and its subsets, natural language processing, and computer vision. Dr. Syed has more than 20 years of research contributions in international peer-reviewed journals, as well as conference proceeding, and she has actually been the inspiration to a number of our students here at the college. So with that, and without further ado, I would like to turn this over to Dr. Syed. Afraz, take it away.
Thank you, Rebecca, for the introduction. Good afternoon, everybody, and welcome to today's talk, How Machine Learning is Transforming Healthcare. Thank you for taking time out and being here today. I'm Afraz Syed, professor here at Mohawk College, and today I'm going to talk about my greatest passion, machine learning, the most active and widespread area of artificial intelligence, or we usually call it AI. So I will keep my video off for the rest of the presentation. And I will share my screen. So let's begin with the tech fact about the future of artificial intelligence. According to a report by Professional Service Network, PwC, artificial intelligence will contribute approximately 15.7 trillion to the global economy by the year 2030. And this has a huge, tremendous potential in this field, according to these numbers. As mentioned, machine learning is the most active area in artificial intelligence. It is due to the explosion of big data, huge advances in machine learning frameworks and algorithms, and great progress in the computational power of the hardware. Machine learning is prevalent in almost all sectors and industries: self-driving cars, recommendation systems, search for new pharmaceuticals, and fraud detections are all applications of machine learning. Healthcare sector is one of the most prominent candidates for the application of machine learning. The pandemic has intensified the pressure on the already stressed healthcare sector. that technologies that can optimize, redesign, and streamline processes, maximize productivity, and generate valuable insights can be the key drives for success. Fortunately, with well-developed frameworks and high computational power of the hardware, machine learning technologies are ready to play a major role in the healthcare sector at both the micro and macro level. Before plunging into the details of today's talk, let me share with you my story of machine learning research. In the early to mid-2000s, Google's popularity in most of the regions around the world boomed. So the researchers and developers started taking interest in machine learning of various languages. At that point, there were very scarce resources available, particularly in languages other than English. Hence, my research contribution in 2010, as you can see on the screen, was one of the pioneering efforts in the Urdu language processing. We proposed and implemented a lexicon-based sentiment analyzer using centi-units. The full version of the research is still available in the Artificial Intelligence Review Journal and is still being cited by many researchers in the NLP community. Later, we extended this model to result into further publications in research journals and conference proceedings. Here is another research work based on 3D texture feature mining, published in the ACM Digital Library. It is the application of computer vision in healthcare. We applied a popular machine learning algorithm called SVMs for the segmentation of the MRIs. So MRIs are medical imaging. One more application of computer vision for medical images was applied on gallbladder sonograms. We implemented a system that named Intelligent Eye, employing imaging and diagnostic techniques for gallbladder diagnosis. Yet another contribution in medicine is an expert system to diagnose multiple diseases using association factor. This is another application of machine learning in the area of digital marketing. In this research, we applied sentiment and emotion analysis on brand tweets. We employed our data set of 10,000 tweets related to 10 technology brands like Apple, Google, IBM, and Facebook. So this was a little bit about me. I'm still discovering and researching in this magical field of artificial intelligence and would love to share some insights with you today. So I will start with the formal definition of the term machine learning, proceeding to a brief description of how the machine learning works. Then we will explore the core concepts of deep learning, computer vision, and natural language processing. At that point, with our newly developed vocabulary and understanding of the concepts, we will see major use cases of machine learning in healthcare. At the end, I will discuss the state-of-the-art technologies and resources available for developing machine learning applications. Our world today is filled with data, a great deal of data in the form of words, text, electronic records, images, music, spreadsheets, videos, and a lot more. Traditionally, humans have analyzed data and designed systems to extract information from at their own. However, the volume of data has surpassed the ability of humans to make sense of it. We are turning increasingly to automated systems that can learn and can help us in the paradigm shift of the technology. So machine learning brings the promise of deriving meaning from all of that data. IBM defines the machine learning as a branch of artificial intelligence and computer science, which focuses on the use of data and algorithms to imitate the way that humans learn and gradually improving its accuracy. Today, we see machine learning all around us. For example, tagging the objects and faces in the digital images, movie and video recommendations on Netflix and YouTube. And certainly the biggest example of all is Google search Every time you use Google search, you are using a system that has many machine learning systems at its core. When you start typing the query, it gives you a recommendation. It gives you recommendations based on your lifestyle and recent interests. Like in this case, Google knows which result to show you first when you are searching for machine, depending on whether you are a scientist or a fan of Machine Gun Kelly, who is an American rapper. A few years back, when a company or business had machine learning in their offerings, it was considered innovative. Now every company is aiming to use machine learning in their products. It's rapidly becoming an expected feature, just like we expect companies to have a website on the mobile phones. To understand the use cases of machine learning in the healthcare sector, we need to understand some machine learning concepts, how it works, and some major types and algorithms. My goal for this part is to give you a big picture of the field and an overview of how the things are working. We will not dive into the mathematical or coding details, but certainly we will discuss some main frameworks briefly. For our purpose, let's split the definition of machine learning into three pieces. These three parts broadly outline the three sides of machine learning, all of them equally important. The first part, using data, is what we refer to as training, while algorithms are used to create the predictive models for making predictions and inferences. Basically, the machine learns to make better judgment through pattern matching and strategic decision making. This process repeats to gradually improve the accuracy. So that is the third part. Training refers to using the data to inform the creation and fine-tuning of a predictive model using a machine learning algorithm, as you can see in this figure. This predictive model is used to generate predictions on new input data, which was previously unseen. Now in this diagram, you can notice that the model is giving the prediction on the new data. As more data is gathered, the model can be improved over time, and hence come the part of gradually improving the accuracy. As you can see here, the improved model. Fundamentally, the vital element for this entire process is data. Everything centers on data. Data is crucial to utilizing machine learning in the best possible way. Likewise, machine learning is the key to unlocking the unseen insights in the data. Here is a quiz for you. Think about the solution of this quiz, and the answer will be displayed in a few seconds. So let's see the answer. So we have the missing things were algorithm training, new data, and improved model, right? So these were the three missing things in the previous diagram. Machine learning discussion cannot be completed if we don't cover the concept of deep learning. For most of the people, it is quite a daunting, heavy on mathematics and coding concept. But as mentioned earlier, I will give you an overview of the concepts and how this fits into the big picture of the things. To explain the difference between artificial intelligence, machine learning, and deep learning, I'm borrowing an image from the research done on machine learning in cardiovascular radiology. This diagram clearly describes the difference between these three important terms. So artificial intelligence is an umbrella term for all the algorithms that mimic human intelligence, including conventional calculators and rule-based expert systems. The expert systems can take decisions based on given rules, but cannot learn for intelligent decision-making, like machine learning does. As shown in this diagram, machine learning is a subset of artificial intelligence. And deep learning is further a subset of ML algorithms. They consist of multiple calculation layers that permit the extraction of high-level features. All these three terms are generally used interchangeably, but most of the time, particularly in the healthcare-related applications or big data applications, when they refer to artificial intelligence, they mean machine learning or most probably deep learning. And when they say deep learning, they mean artificial neural networks. Artificial neural networks are at the heart of deep learning algorithms. Their name and structure are inspired by the human brain, mimicking the way that biological neurons signal to one another. So deep learning algorithms or artificial neural networks attempt to draw comparable inferences as humans would by constantly analyzing data with a given logical model. And that is the key thing in the neural networks. To explain it further, I will dissect the definition of deep learning into two pieces: multiple calculation layers and extraction of high-level features. Extraction of high-level feature is the main difference between the simple machine learning and deep learning algorithms. The extraction of features is only possible if we have multiple layers and very large data sets for automated training. For understanding the feature extraction, let's extract the example of program for identification of various types of leaves. Certainly, we need some features like order of venation, outline, shape, or size of the leaves. These features will make the identification process possible. If we apply a simple machine learning algorithm, we will have to tell the program about the features based on which the leaves can be differentiated. With deep learning, on the other hand, the features are picked out by the neural networks without human intervention. Obviously, that kind of independence comes at the cost of having a much higher size of data to train our model. And this is the main reason of recent popularity of deep learning algorithms. They work exceptionally well with the high volumes of data. Now let's expand on the second part about the which was about the multiple calculation layers. Here I have created a simple neural network, but the current neural networks we use in research and development are so huge that they need hours or even months to train. These networks can run only on specialized hardware called GPUs or graphical processing units. GPUs are designed with thousands of cores to exploit the inherent parallelism of the ANN models. So a neuron is the core entity of a neural network, where the data processing takes place. The data is fed to the neuron in the first layer called the input layer. On the other end, the last layer is called the output layer. Then there are multiple hidden layers to transform the information from one layer to another over connecting channels. For each, these connecting channels has a value attached to it, and hence it's called the weighted channel, as you can see here. All neurons have a unique number associated with it called the bias. The processing of the neuron and transfer of information to the next layer depends on these two values. Let's consider the green neuron as an example, this green neuron. The bias for this neuron is B11. This neuron needs to be activated to pass the output to the next layer. So there are 4 steps of this activation process. First, the weighted sum of the output of the neuron is calculated. Second, the bias is added to the weighted sum. Third, the result from this calculation is fed into an activation function. The outcome of the activation function determines if the neuron gets activated or not. Every activated neuron passes an information to the following layer. This continues up until the second last layer. Finally, the neurons activated in the output layer create the predictions we are looking for. The bias and weights constantly adjust to generate a well-trained neural network. So we can summarize these steps as adding the weights, adding bias, and then activation, feeding this to activation function, and then the neuron fires. Here is a quiz for you. Think about the solution for this quiz. And again, I will show you the answer in a moment. So here we are going to arrange the following steps in order for the working of an artificial neural network, which we have just learned. So the ordered steps are calculate the weighted sum, add bias, then feed this result to the activation function. Then the neuron activates and bias and weights are adjusted for more accuracy. This is the last step. Now is the time to look into two major subfields of machine learning, computer vision and natural language processing, or NLP. So computer vision enables computers and systems to derive meaningful information from digital images, videos, and other visual inputs and take actions or make recommendations based on that information. In other words, computer vision focuses on developing techniques and methods through which machines are able to understand and sense their surroundings. For example, image detection, object detection, scenes reconstruction, image and video pre-processing, and scene segmentation are all types of computer vision. One major use case of machine learning in the healthcare is processing of medical images for disease diagnosis of various medical conditions. Medical resonance imaging, or MRI, is a medical imaging technique used in radiology to form pictures of the anatomy and physiology processes of the body. The MRIs are used for disease detection, diagnosis, and treatment monitoring. There are various MRI datasets available for machine learning applications. Let's consider an example of a brain MRI dataset to predict the diagnosis of a cyst, tumor, or bleeding. For all the machine learning projects, the very first step is called data cleaning or data processing, pre-processing. This step makes the data ready for the learning model. Pre-processing of the images can be done using various techniques. For example, removing the background color for your image to reduce the noise, or converting color images to grayscale to reduce computational complexity. Also, resizing the images in the dataset to a unified dimension. And if you have a small dataset, you can use the technique of image augmentation. Image augmentation means artificially expanding the dataset of images, and it can generate 3 to 4 times more images. So when we feed this augmented dataset to our neural network, the model recognizes objects with improved precision and accuracy. In brief, any adjustments that you apply to your dataset are considered a sort of pre-processing, and you will pick that technique based on the problem you are solving and the dataset at hand. Sorry about that. So, in brief, okay. So after the pre-processing, the dataset is ready for testing and improving the algorithm as shown in the diagram. When model is exposed to new data, it can predict the diagnosis of a cyst, tumor, or bleeding. This was a brief introduction of the computer vision. Let's move to the next subfield called the natural language processing. So NLP, or natural language processing, is a branch of artificial intelligence that helps computers to understand, interpret, and manipulate human language. NLP combines the fields of artificial intelligence and linguistics. NLP interprets natural language structure and rules to make models which can comprehend, break down, and separate significant details from the text and speech. Before applying the machine learning algorithm, we need to process the text document through some steps. You can see them here. Segmentation is the first step of NLP. Segmentation means splitting the entire document into sentences with the help of punctuations and the stop words. Next step is tokenization. During tokenization phase, each sentence is split into separate words called the tokens. Then we process individual token for lemmatization to generate lemmas. For example, in the words run, runs, running, run is the lemma. Or in the words break, breaks, broke, and broken, break is the lemma. The next step is to tag the nouns, verbs, articles, and other part of speech. So this is called part of speech tagging. After post tagging, the named entity or any tagging is done. This involves identification of references, everyday names like names of the movies, known personalities, or locations. So to demonstrate these steps, I'm using Stanford's Core NLP online demo version. Core NLP is an NLP platform developed by Stanford NLP researchers. Let's start with the popular sentence, the quick brown fox jumps over the lazy dog. So I enter the sentence and press submit. And here is the result. As you can see, the post tags DT for delimiter, JJ for adjective, NN for nouns, VBZ for verb, and IN for preposition. We also have lemmas. So jump is the lemma for jumps. Also, the whole sentence is recognized as it is by the named entity recognition algorithm. Let's see the second example to analyze the sentence. Mark Zuckerberg is one of the founders of Facebook. So if we see the results, post tags and lemmas are identified. Also notice the NE tagging for Mark Zuckerberg and Facebook as person and organization. Now our text is ready for training the learning algorithm. One important application of NLP in medicine is mining the electronic health records, or EHRs. So here we are applying the machine learning on EHR data set. The choice of algorithm certainly depends on the factors like the data volume and application type. Here is another quiz for you. Think about the solution in a few seconds and I will show you the result. So let's see, the NLP steps are starting from segmentation, which is the first step and results into the sentences, then the tokenization, which results into the tokens or the words, and then the lemmatization, which results into the roots or the stems, and then the post tagging, which results into the tagged words with the part of speech tagging, and any tagging. This is the last step, named entity tagging. So this is the NLP process. Healthcare sector is one of the best candidates for the application of machine learning. This is because of the complexity and exponential rise of healthcare related data. Today, machine learning is transforming the clinical decision support systems and managerial processes by early identification of disease, tailored treatments, precision medicine solutions, and a lot more. So here we have another tech fact about stethoscope. Stethoscope was invented by Reinin Theophile in 1816, about 200 years ago, and still it is quite, it's being used as the major symbol of the health professionals, and this is quite interesting. Let's start with a few numbers. According to this research published in the late 2020 about the projected growth in global healthcare data, the amount of global healthcare data is expected to increase dramatically by the year 2020. Early estimates from 2013 suggested that there were about 153 hexabytes, which is a new symbol for the data. Not that much new, but still about 153 hexabytes of healthcare data generated in that year. However, projections indicate that there could be as much as 2,314 exabytes of new data generated in 2020, which is a huge difference from the estimated growth. Partly this is due to COVID-19, but now we cannot expect to go back to previous numbers. Most probably the data, the numbers will increase exponentially. According to another research article published in 2018, by 2025, the compound annual growth rate of data for healthcare will reach 36%. That is 6% faster than manufacturing, 10% faster than financial services, and 11% faster than media and entertainment. So this is an interesting article about how digital twin technology can disrupt the healthcare sector. Digital twins are virtual models of physical devices that enable real-time decision-making through predictive simulations to generate valuable insights. This can be achieved with a combination of machine learning algorithms and specialized hardware. The researchers are anticipating a number of advantages by using this technology in the healthcare. For example, early disease detection through patient monitoring and early detection of epidemics and pandemics, or personalized healthcare. Radiology is the medical discipline that uses medical imaging to diagnose and treat disease within the bodies of animals and humans. Machine learning has already dominated this area of medicine. In 2018, a deep learning-based algorithm was developed. Using more than 50,000 normal chest images and almost 7,000 scans with active TB. The algorithm has become so good in performance tests that it easily beats the radiologists. Oncology is the branch of medicine that deals with the prevention, diagnosis, and treatment of cancer. In this area, most machine learning research has focused on using genetic sequencing, clinical imaging, and images of histopathological specimens to diagnose cancer or as early as possible. This image is shared by Adam Jala, a computer science researcher at MIT. As you can notice, an AI system indicated a woman's potential breast tumor 4 years before it developed. And this is really amazing. So these were very few use cases of machine learning in healthcare. A lot is going on in this sector with tremendous potential of growth and research. So now is the time to visit the Canada's first smart hospital. So let's get inside.
Mackenzie Health represents the future of healthcare. It's the integration of the underlying infrastructure, the network, and the technology to a patient-centered experience in healthcare. That's the future. We started to take a step back and look at technology, try and understand what we needed from a provider perspective, from a patient perspective, and how we wanted to deliver care, and ensuring that the patient experience is at the center of everything we do. We're lucky to have this opportunity to build this world-class medical grade infrastructure to drive this smart hospital to the next level. So what we knew at the very beginning was you needed solid infrastructure. That's where CompuGen comes in. CompuGen is what is called a solution provider. We provide the underlying technology infrastructure that enables businesses to actually do the kind of work they need to do in a digital economy. We want to use technology in the right way to give our patients and families control of the things in certain circumstances in a very high stress situation. We have tablets deployed for each of the patient room. And that enables the patient in their room to have access to a whole host of technologies as they can order their food, turn down the blinds, or turn down the lights. It's empowering, I think, the user to be as empowered as they are in their day-to-day lives. So this hospital has the fully integrated smart technologies. One example we have, Code Blue is the hospital medical emergency. And once the clinician press a button on the wall, the nurses and the clinicians will receive the alert instantly and help clinicians to make decisions faster and better for all patients. This project is so exciting because we are creating world-class infrastructure to help to deliver world-class care. We actually had folks at CompuGen who put their hands up and said, I want to be part of this project. I don't ever get to build a hospital from the ground up. This is a remarkable opportunity. I think CompuGen was able to listen to us. CompuGen was able to say, we don't know exactly what they want, but we know this organization is a forward thinker. So we're prepared to take a bit of a risk and understand their needs along the way. Our goal was to help them do what they needed to do in a very complex environment. So it's that constant dialogue and that understanding of what the needs of the hospital are and really what the technology solutions would be to support that. So I think we have a very unique and specific partner that is very much committed to this organization.
It was very exciting working with the Mackenzie Health team. I'm proud that CompuGen has been able to be so instrumental, so attached to patient outcomes in healthcare and the outcomes that Mackenzie Health was trying to drive.
So what I'm most proud of at the end of the day is, all of the sophistication that I've talked about in this technology solution doesn't really mean much unless we're keeping patients safe, we're delivering high quality care, and the experience for the patients and their families is the highest level.
So that was cool. So our next topic is machine learning technologies and resources. And here I'm going to give an overview what resources and technologies or frameworks are available. So if we look back a few years back, machine learning developers used to implement deep learning algorithms more or less from scratch using Python and NumPy. It is good to understand the working of these algorithms, but when you want to implement more complex and large neural networks, it's not a good idea to implement everything from scratch. Fortunately, there are now many good deep learning software frameworks that can help you implement these models. Today, we will discuss two most popular frameworks, TensorFlow by Google and PyTorch by Facebook. Most of the machine learning you see on their website is powered by these two frameworks. So let's begin with the tech fact about Ada Lovelace. Alan Turing, I think we all are aware about Alan Turing's first modern computer, which was built in 1940s. And that was basically an inspiration by Lovelace notes on the analytical engine. So that is why she's considered as the first computer programmer. So let's look at the Tensorflow, I think, which is the most popular framework for the machine learning community, developed by Google Brain team. Tensorflow is an open source library for numerical computation and large-scale machine learning applications. Though TensorFlow is written in C++, but you can use Python as an interface for using this resource. It is mostly used for deep learning applications and provides an accessible and readable syntax. PyTorch is developed by Facebook, their AI research lab. This is an open source tool as well. And as obvious from the name, Python, it is Python based and fits well in the Python ecosystem. PyTorch is well documented and therefore is considered easy to learn. One prominent use case of PyTorch is building rapid prototyping. When comparing both the frameworks, both can be used for deep learning in addition to other machine learning algorithms. TensorFlow is currently better for production models and scalability. PyTorch is easy to learn, but most probably the selection of the framework or library depends on your project and the nature of the data set which you have. So the next very important resource is Nltk, which is the natural language toolkit. This is perhaps the most significant and largest resource for the natural language processing community. It is Python-based resource with over 50 corpora and lexicons such as WordNet. It provides easy to use interfaces which allow you to use multiple resources for multiple NLP applications. And also it provides you with a suite of text processing libraries for almost all NLP tasks, like classification, tokenization, stemming, semantic reasoning, tagging, parsing. You can name them. So it contains all kind of information. Particularly, it is very advanced in the English language. So this was a little about the frameworks. Now we will talk about the machine learning communities, which is a very, very important aspect as well. So the machine learning community is very strong, accessible, and helpful. You can find code, packages, libraries, and blogs for almost everything. There are a number of communities. Today, we are going to just see 3 of them. So Kegel, online community, developer communities from the respective frameworks, and GitHub. So Kegel online community is a branch of Google LLC. It is an online community of data scientists and machine learning professionals. It allows you to build models in web-based data science environment. You can find and publish data sets from various sectors. You have a huge options of the data set on Kegel. Also, you can collaborate in projects with other developers and you can enter competitions. This is quite an active community. Also, you can collaborate. Okay, so the next one is for all the discussed frameworks like TensorFlow, like PyTorch, Nltk, OpenCV, they all have their dedicated developer communities. So as you can see in this screen grab, this is the screen grab of the TensorFlow community. So it means when you will go and find the TensorFlow community, you will find that community which is particularly working with this particular framework. Then you can find a community for PyTorch or Nltk. So that is a good idea to find communities as well. The very important GitHub is a code hosting platform for version control and collaboration. It is a great resource for developers to share and collaborate. It includes a number of dedicated communities for machine learning frameworks. Like here, we have GitHub community for TensorFlow. So you can see that how many people we have, projects, repositories, 101 repositories. So this is basically a community for the TensorFlow flow developers. And this is the community for the PyTorch developers. So the same statistics, you have the repositories and you have the projects, etc. We still have one piece missing of the puzzle, and that is finding the reliable and practical data set of text or images. In this regard, Google's dataset search is a great tool. Just like the query results, it brings the data sets for you from all possible sources, and certainly they are ranked according to their popularity. Let's see a demo in which I searched for the data set related to brain MRI images for brain tumor detection. So you can see Google gives me a list of 25 available data sets. I can filter the results for free data sets, making it 24. So the first data set is available at Kegel, and it's also available to download. So here are the rest of the data sets which are available. Also, another thing you can see here is, which is highlighted at the moment, that there are 94 scholarly articles citing this dataset. So it basically is an indication of authenticity and quality of the dataset. Also, you can find some information about the authors, license, and description. So if you want to go to the website of the dataset, you can see it there as well on the Kegel website. Here are all the details about size, number of files, and everything related to this data set. Moreover, you can see at the top, there are codes, tasks, discussions available. So it means there is help available as well for using this data set. So this was the last topic for today. We have reached to the end of the presentation. So we talked about machine learning and deep learning, discussed computer vision, preprocessing and applications, explored how machine learning is transforming healthcare by looking at some use cases, and finally looked at some resources available for developers. I would like to share final thoughts about my idea about the machine learning. So today we are using machine learning to make humans' tasks better, faster, and easier than before. We can also look further into the future when machines can help us do ventures that we never could have accomplished on our own. In healthcare, we have a number of such opportunities which can change the medical landscape. Fortunately, it's not hard to take advantage of machine learning today. The resources have gotten quite well. As we have seen, there are a number of frameworks. All we need is a good framework, data set, and we know where we can find the data set, and eagerness to take the plunge. So these are my final thoughts. Thank you very much. And let me know if you have any questions.
Dr. Syed, that was so interesting. My brain hurts a little bit, I'll be honest. But I have to compliment you on taking a very complex subject and breaking it down into pieces that are not only more easily understood, but applied. Thank you.
Thank you very much, Rebecca.
Actually turn it over to Marita to provide some sort of closing remarks. But in advance of that, you did ask if anybody had any questions, and I'd like to put that out to everybody. If anybody has any questions, because I know I have a few. If anybody has any questions, yes, go ahead, Ariel.
Hi. First of all, I wanted to say it was a really great presentation. Like really interesting. So my first question was, what do you recommend to someone who is interested in the subject or field, and where they should start if they don't have a lot of background in it?
So as I mentioned, if you are in Mohawk, we are teaching Python. So if you are good in programming in Python, then I think you can go for the libraries. We have some Python libraries, or even you can go for the frameworks. So TensorFlow have a full-fledged community, and because it's by Google and they are investing a lot in the healthcare and in the big data. So I think this is a good idea that if you already have a programming background in Python, go for either PyTorch or TensorFlow. I think this is a thing. And I have also given you how you can get the data set. So you can rock.
That's awesome. One thing, Ariel, that I will add to that is for people that are interested in data and healthcare, Mohawk does have a brand new digital health degree. And for our current graduates, from our computer science software engineering area, we also have that as a graduate certificate. So you can check those out.
Yeah, this is great. Thank you, Rebecca.
No, thank you. That was a really good observation, Ariel. Thanks. That's perfect. Does anybody else have any questions? Don't be shy. Ariel.
Okay, I just have one more. So some people are like really hesitant to trust machines and, things that they don't know, especially when it comes to things like your health. So how do you think this will be received once it's more common in the healthcare field? And what would you recommend a doctor or nurse tell their patient if their patient is concerned about the results or how this machine works?
Yes, so in fact, this is already a huge challenge. You can consider this is a huge challenge, but still, because there are a number of benefits as well. So when I was preparing for this presentation, I just went through a paper in which Google is doing a contract with the hospitals in America, and they are looking for a contract in which they can use the patient data with, of course, some restrictions. So of course there will be some challenges, but the research, as you can see, we can detect the cancer. There is a possibility of identifying the diseases. A lot of things are there. So the idea is that we need to get the data from the hospitals and under some contract, right? So now what they are working on is they are trying to use the data, of course, without declaring the identity. Right. So this is a thing on which the research is being done, how we can use the health records without going for the identity of that particular person.
So
awesome. Thank you.
Yeah, that's a great question, Ariel.
Yeah, thank you very much.
And thanks for the answer, Dr. Syed. I had the same thought, kind of, and especially when you were, I had to make my notes here. When you were talking about the data sets themselves, a related question to Ariel is just how are these data sets validated in terms of accuracy and even more so in terms of legitimacy?
So that is, in fact, as I mentioned during the presentation as well, that this depends because the data sets are being used by the researchers, And these are, of course, the researchers are asked to apply some research on these data sets by the hospitals or by the healthcare organizations. So if an organization is giving the data set to the researchers for their use or for research, so it means that is an authentic data set. So we can find the authentic data sets by going through what is their citations, right? So when I was searching on the data set, you just noticed that there were 94 citations for that particular data set. It means that was used or cited in 94 research works. And then you can go to those research works and see that, okay, these are proper authenticated research works, publications, and this will show, will let you know that this is an authentic data set.
Okay.
Basically, this is a venture of not only the machine learning community, but also from the hospital. So both are participating in this thing.
Okay. It was interesting when you actually filtered the data sets, how when the number went down when you clicked on free, but not too much.
Yes.
Right. I guess these things are available at no cost.
Yes. Yeah.
Places. Yep.
Because they need researchers. That is the thing. They wanted to want us to explore more.
So open source.
Yeah, open source. Yeah, available for research. And as I mentioned, this is a very key research area as well. How you can just create anonymity in the database. How you can make the the electronic records without identifying the particular person. So this is a research area as well.
Very cool. I'm going to ask a personal question, if you don't mind.
Sure.
So thank you so much. You did share with us your the incredible work that you did at the very beginning, a lot of the research that you've been involved in. If you don't mind me asking, how did you get to be where you are today? Where did you go to school? What programs did you take? Is that something that you wouldn't mind sharing with us?
Yes, sure. In fact, I did PhD in artificial intelligence. And before that, I did master's, MPhil, and bachelor's. So it was a long path. So I did bachelor's in mathematics and physics. So I think that was the place where which gave me the background for the mathematics, the whole thing. That is why I think why I just got stuck in machine learning idea. So that was the mathematics background. And then this is basically, then I worked in the university for around 20 years. Okay. In Pakistan and in Saudi Arabia. And then I came in Mohawk College.
Fantastic. Well, we're glad your journey ended up bringing you here.
Yes.
We're very lucky. I did have, I guess, one more question, if you guys don't mind me asking. And I guess when it comes to, you talked about some really interesting companies, and I'm just wondering, are these potential destinations for places for our students to work? For example, Compugen, Mackenzie Health, that smart hospital. Like, that was super interesting.
Yes.
Could our students get jobs at places like TensorFlow, PyTorch, Nltk? Where do you think our students might be able to expand their career aspirations?
So we are, as you mentioned, we are offering a digital healthcare degree. And that will be, of course, that will open a lot of things for them. TensorFlow and PyTorch they are basically not the companies, they are simply the frameworks or technologies in which they can work and develop. But of course, the healthcare, as you mentioned, Mackenzie Hospital, once they are done with their degree, or basically what they are working on at the moment is smart hospital, and they are implementing the IoT with the machine learning, right? So that is already being done I think in our IdeaWorks. So they are already working in the IdeaWorks in this field. And I was looking at some projects which they are doing to employ Internet of Things. So that is the same idea in the smart hospital.
Perfect. Thanks, Dr. Syed. And I'm glad you mentioned IdeaWorks. In case you guys don't know, Google it. Mohawk IdeaWorks. It's the applied research
that is
of Mohawk. And
they are doing a lot of work, I think, on Internet of Things, especially. And after we will go through, complete this, start this digital healthcare degree, I hope we are looking forward for more openings in this area as well.
cool. Yeah, there's the whole mHealth and eHealth area that IdeaWorks runs too, right?
Yes, yeah, they have.
Which if there's anybody here who hasn't been on campus actually yet, and in your journey here at Mohawk, when we do go back, it's cool. Take a walk down E-Wing, and as soon as you enter E-Wing on your left-hand side, you will see.
IdeaWorks, yeah.
Yep, very cool. So does anybody else have any questions? All right. I would now like to turn this over to Marita. Marita, over to you.
Hi, thank you so much. Hi, everyone. I'm Marisa Lindy. My pronouns are she, her, and I am the Vice President of the MSA side of WiTT. I'm also in my second year of software support. So I'm a student at WiTT, and I also work as a student assistant to WiTT. So I have my hat in all kinds of different directions, but it's really great to meet all of you and have all of you here today with us. I would love to, first of all, thank Dr. Syed for being here. I know that you're probably very busy, so I would like to thank you so much for coming out and giving such an amazing, informative, educational talk that I know it taught me like so much. And it was really, really interesting and fascinating. So thank you so much. And thank you so much to Rebecca for giving such wonderful opening remarks. I apologize if the dogs in the background of me right now. But thank you so much, everybody, also for coming. Ariel, Nicole, and everybody else who's here. I know this is a really busy time of the semester for you. I know you have a lot going on, so it really means a lot that you came out tonight. And we're here, and we really, really appreciate it. We couldn't do it without you. And also, definitely want to let you know that WiTT has a lot of really cool events coming up. We have another WiTTConnect, which is happening on December 10th, Friday, December 10th. And I believe it's just going to be like kind of an exam week respite. We're going to play some games. We're going to relax. We're going to have some fun. It's a really great chance to meet everybody who's involved with WiTT and kind of just chill, because I know you're really stressed. And we also have an amazing alumni panel coming up in February, and our next symposium coming up in March. So feel free to check out our website, mohawkcollege.ca/WiTT. It's got all of our events. And thank you so much again for coming. It was a really great event. And thank you, Dr. Syed, for coming out.
Thank you very much all for having me here. Thanks a lot.
Really
have
great.
a good evening.